All right, yeah, so Rebecca Graff and I, we farm, Fair Share Farm, we began in 2003. So this is Rebecca and me a few years ago. We're on her family's land. It's 260 acres, and then we rent about 20 acres for Fair Share Farm. She's the fourth generation of her family to farm it. It was originally bought by her great-grandparents in the 30s. You can see here's our vegetable operation with the alley cropping, and then there's native grasses in the other portion of the farm, and then there's some pasture off to the left. So I wanted to kind of acknowledge our land and what it's been over the millennium and ages. So as many of you know, back in the 1850s, 1820 to 1865, Missouri was a slave state. We're in Clay County. There were over 3,000 slaves in Clay County. If you go to the slave schedule, the farm across the road from ours had slaves listed. So, you know, African Americans were enslaved and used as labor, at least on the adjacent farm, if not on our farm too. Prior to that, the United States purchased this called Section 69, that yellow area, in about 1808 from the Osage. And that whole area was used as a hunting ground, really, for the Osage and the other tribes in that area. So we're on ground that's been used by different cultures for thousands of years. And now we're stewarding the land. So this is a Lidar map of our farm we got a couple years ago. So if you're planning on doing any agriculture on a piece of ground, if you can get this from USDA, it'd be extremely helpful. You can see down here, well, there's two spots. P1 is where our original pump was. This is an old irrigation pond that was put in the 1950s. Conservation program, Rebecca's grandfather did that. The P2 over here is where our current system is. The Lidar map, these are 2-foot contours. So you can kind of see, so say we're trying to get the water all the way up here, this kind of highest point on the farm. You get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So it's 26 feet of elevation to get water to the highest point on the farm. And so we have to have enough energy in our pump to do that. This was our original pump. It came out of that irrigation pond, the old one. It's full of duckweed and kind of still is. It's more of a wildlife pond now. So we had this gas-powered pump. It was noisy. You have to run to the gas station all the time to get gas for it. The only convenience was that when it ran out of gas, it would turn off, so you wouldn't have to go turn it off. We have a filter there. It was a disc filter, and we'd have to back flush it to clean it. And then you can see that blue lay flat hose. We had to lay that out across the entire farm to do our irrigating. And so that was a real pain every year. This is kind of more the layout of our current system. These are 2-inch underground lines. We have a block that goes off here to the left. This is what we call our home field. And then over here in our pond field, we used to have rectangular blocks. So you can kind of see these pipes were laid out along our roadways. This is our current layout with our alley cropping and berms and swales. So we're still kind of incorporating our hydrant locations into our new farm layout. It's working fine, but it's just another thing to incorporate. The lines are about 18 inches down, so we're able to till over the top of it. So luckily that doesn't matter too much. So in 06, like I said, we figured it was just too noisy to, and it wasn't very sustainable and environmental to have a gas pump going all the time. Henry Rentz, that's the gentleman there on the left, he designed and built this system for us, 4 solar panels, and a Grundfos pump. So this is the pump. It's like a well pump that you can put in a well. We float it. We have floats, so it floats on top of the pond. It can run on AC or DC power, so that's nice. You can see this blue cord here. That's the power lead, and then we have to get that power all the way back to the solar panels. And that's a target for muskrats, and I'll talk about that later. So this little curve here, I don't expect everybody to know kind of how to read a pump curve, and this one's a little different even than a lot. But you can see down here, this is the number of watts that your system will put out, whether it's windmill or solar or alternating current. And those solar panels that we originally had put at about 450 watts. So up here at 30 feet, you know, say we have to lift it 26 feet. Actually, we would then have other losses. When we had that blue hose, you'd have a lot of friction loss and a lot of leakage and all the fittings. But anyway, if you only have 30 feet really of pressure you have to compensate for, you could get, you know, 23 or so gallons per minute out of the pump. I'm not sure we were really getting that originally. And this is the way it's laid out. So you have your solar panels. Power from the solar panels comes back here to this CU200. It's a Grundfos controller. And so it'll take that power and provide it to the pump in a controlled rate so that the pump will operate properly. And then they don't show it here, but then there'll be the hose that'll come out of the pump and it'll go into your irrigation system. So it's really pretty straightforward. You just need the right equipment. And this is the controller. You can see it here. So you got your solar panels and the power comes into this, and then this blue line, the power goes out and goes down to the pump. And then the pump comes out and the water goes wherever it is that you want it to go. So this is our controller. So you can kind of see there was a 280 watts. So that was back when we originally had it installed. It might go up to 400 or so. When it's pumping, you have these green arrows that show that it's moving. You can either have solar power, wind power, or alternating current. And then here's your little buddy with the wrench. And we had quite a few times over the years where that red light would go on. And it seems like almost always it was that the line was chewed. So even after all these years, the pump's still going. The pump is really pretty high quality. So this was our original setup. The pump was attached at this end of this pipe. This was meant to be like a pressure tank, but there was really too much leakage for it to just fill with water and hold water, and then us be able to go out wherever and open a line and have water flow. So we have to kind of turn it on and off every time we use it. And so then it came through this filter. This was like a fertigation system we used way back when, you know, went out to the field. This is how we have it laid out now. Here's our 2 panels, and this is the float. So the pump we put in kind of the deepest part of the pond. We had this dam built in 2006. It drains a large area, so we're kind of lucky. It can be full in the spring many times. So we had to tie it off so it stays in one place. In 2010, the stimulus through the Obama administration, we were able to get a grant to put in over 2,000 feet of 2-inch PVC pipe, as well as buy a second solar panel array. So we got 75% cost share on the materials, and then we did all the labor. So here we are putting in the trenching, just rented a trencher. This piping here, it's 2-inch water pipe. So it has these bell sockets here, and you just push them together over the length of, where you're going. This is how we have our hydrant. You just had a little T, and then we came up and had a valve there. It's an example. Here's our hydrant down here. The plan was to put these hydrant boxes over them, and we pretty much have that, but even with those boxes, they're still in danger of tractors and other things, but they're not too deep to dig up. So if you're putting in a system like this too, you need what are called thrust blocks. So this was a T, so water's going out through this way as well as this way. And if you don't have something to hold it in place at some of these connections, it can just blow apart or move significantly. So you need to brace it with a little bit of concrete at your turns and other areas like that. So here's our existing system. We got this second solar array. You can see here's our old blue hose stored away. And once we got that, we go back to this graph. So now, like a day like today, we're getting a good 900 watts of power from the sun. You can see this is showing, at least on the graph, you can go from 23 to 33 gallons per minute. That's a 50% increase. And, we've really seen it. This is more the size system that we needed to move water from the pond to anywhere we want on the farm. So when we irrigate, we tend to irrigate in blocks. We can have more than one hydrant open at a time. We have more than one filter. And we don't necessarily do calculations. It's more just a matter of, if we have more pressure, we'll turn on more T-tape. If not, we'll just have to stick to a smaller area to water that day. Depends on how sunny it is and a lot of different things. And if you're not familiar with friction loss, so this is an example. Say we have 30 gallons per minute in our line, and it's our 2-inch PVC pipe. This is saying for every 100 feet, you basically have the same amount of energy, need the same amount of energy as you would to lift the water another 1.6 feet. So, if you have 1,000 feet, that's 16 more feet of elevation equivalent that you're going to have to overcome with your pump. So you just got to think of the pump as, just energy. How much energy is needed to push the water to where you want to get it? And is your pump strong enough to do that, and then have pressure left to get it down the T-tape after all that? This is about how much comes out right at the pond. Measured at one time, it was probably 30, 35 gallons a minute, somewhere in there on a sunny day. And if you do it at a hydrant, it's probably 25 or so. We haven't really done a lot of testing that way. We just kind of go with things based on how they're performing at any one point in time. The other thing that's nice about solar is that, for one, it's independent of location. That's one reason it was in that stimulus package. We actually got money through the Department of Energy for remote solar irrigation systems in agriculture. This system could be any pond anywhere, which is kind of nice. And when the sun's shining, that tends to be when it's hot and dry. So that's when it performs the best. So that's a good part of having a solar system, is that it works well kind of when you need it. So I was talking about a few of the problems we can run up against. You can see here these little gnaw marks. So this isn't the first time we repaired this line. This last time I did it, I didn't have maybe all the materials I needed. So these wire nuts, they were actually a type that had like there were some that had like a gel in them, and they're supposed to be for waterproof systems, and then you put a heat shrink around it. And it kind of lasted a year, but that line moves around so much that that heat shrink tape can just become separated from bonding to these wires, and then water can leak in, and then stuff rusts away. And then the guy with the wrench shows up on the control panel. So this year, that was a problem. After we'd run the pump for a little while, this is really more of the type of system you'd want. What's nice is the one I just got this year, they have this like tape where you wrap it around these wires. So when you take this piece of heat shrink and you put it over it and you shrink it, you have it seals to this as much as to this, you know, flat wire. You have something round sealing to something flat. So we're hoping that this is really kind of the best system for getting that together. And another thing we, took us 15 years to figure out what you can do to protect this. We had tried all sorts of different things. Just take an old piece of garden hose and slit it in half and just slide it over the top of this electric cable, at least around where the pump is, because that's where, at least in our experience, that's where kind of the critters go after it. I don't know if they think it's, something that's invading their territory, but it's a regular thing. So that helps protect the wires from gnawing. It doesn't have to be waterproof. And then this is the hose that comes out of the pump. It's almost like a vacuum cleaner hose. It's got like wire in it, and it's pretty sturdy. But even with that, you can see here, the pump's running right here. Apparently there's a few leaks in the hose. You can see kind of water that's probably squirting up from some type of a pinhole or other leak in the line. So that's something to consider. The floats, they're another thing. We've gone through a lot of floats. They'll get gnawed and then they'll just fill with water and sink. We've used like gallon jugs, same thing. And we did this last time, we almost made like a little raft of 3 of these floats and wrapped it in chicken wire. And that seems to be working the best. So that's mainly it for the solar. I think I have a few minutes here just to kind of show you a little bit about an aspect or two of our system. So this is a hydrant setup that we might have. So here's the hydrant with water comes out, and then at the beginning of the year, we'll hook up to that. This is a filter system as well as a fertigator. There's a check valve there. This fertigation system, this piece of Tygon tubing here, you can put over into a bucket and play with these valves, and you can bleed whatever you want into the system. Here's our filter. And then what we do, instead of have a lot of valving with our headers, the cost adds up, but we have a lot of these kind of fire hose, quick disconnect cam lock fittings. So in this case, the water comes out of the hydrant, comes through the filter, and then it comes over here. And then if we want it to go over here, we'll just connect that. If we don't, we'll plug it there, and then it'll go a different direction. So we just use plugs in the cam lock fittings. And so kind of anybody can do it. You don't need to be unscrewing fittings or buying a lot of valves. So that's pretty handy for us. There's just kind of a close-up of it. Always have the arrow for flow in the right direction. That always helps on the filter too. This is a disc filter that Carrie was talking about. So we have this one, it's a little bit larger one. We also have a smaller one that's not attached to a system like this. You can just have this in your line, and that helps. This is one of our farm hacks. So one year what we did, we were just getting tired of the pins tearing our row cover. And so we kind of made them stapled like that, and it used up a lot of blue hose, and it helps some with the row cover with ripping when you use those pins to hold it down. And then what we'll do, we don't have an underground below ground system like Carrie was talking about, but we will put some pins like this along the area where we're watering. And that way you just have to go down to the end and kind of pull it, and you'll pull it straight, and that helps with that.